Hello and welcome to your Physics Unit 2 unit preview. This is the first unit of Quarter 2. My name is Andrea Troxel. I am the 8th grade Science CTL and I am at Infinity Preparatory Middle School. You can email me at atroxel@uplifteducation.org. For physics, there are two major ideas: describing motion and also the math involved in physics. And so along with motion, there is a general conceptual understanding. Can you describe how these objects are going to move? And those objects would move due to unbalanced forces. Can you describe speed, velocity, and acceleration? And can you describe how objects will move based on Newton's laws of motion? There is also a math component which deals with calculating. This year, the scholars will be able to use a calculator on the Science STAR test. Scholars will need to be able to calculate net force, use the force equals mass times acceleration formula, and use the formula for speed, which is distance divided by time. Please use in your classrooms and remind scholars frequently about the formula chart, which would be provided in their STAR test, and provide those charts for scholars whenever they are working in your classroom. Your physics unit should take approximately 10 class periods, and that's if you include the GRASPS assignment and the unit assessment at the end. The key concept for physics would be with systems, and our related concepts are movement and function. With systems, we're talking about interacting components, and with movement, of course, we're talking about motion, and with function, we're talking about the math portion of things. So our big ideas will directly relate to those related concepts. The statement of inquiry for physics is the movement of objects and systems are expressed as functions that can be used for engineering and progress. The inquiry questions for physics are not very big picture. I had a very hard time coming up with questions that did not involve the math language or physics language in some way. When you start looking at interdisciplinary units or you start looking at cross-disciplinary units, these questions don't really apply to some other disciplines. So when you are writing your unit plan for your school, see if you can rework these questions into something that's a little more applicable to some other disciplines. Unlike the standards for the chemistry unit, where all 5 standards are readiness standards and will be tested on the STAR test, on the physics unit there are only 3 standards, and one of them is a supporting standard. So if you find yourself getting crunched for time, there is a supporting standard which deals with speed, velocity, and acceleration that you can condense into maybe 1 or 2 days to give yourself more time to explore balanced and unbalanced forces or the applications of Newton's laws. This is an excellent unit to allow scholars to explore and gather data and then manipulate that data using mathematical equations. Some very obvious interdisciplinary connections involve mathematics and technology. In math, of course, you are using your calculations and also graphing data. In technology, you can work together with your technology teacher or see about getting computers for your room so that scholars can actually use an Excel program or Google Sheets to enter data into a data table and then have the program create a line graph that represents their data. The GRASP assignment for this unit deals with the debatable question that asks why we are still using the ideas of 1600 and 1700 in science today. And so scholars are going to be pretending that they lived at the time of Sir Isaac Newton, and they need to describe these laws of motion to people that are alive in the 1600s. They will create a newspaper article that gives descriptions of experiments that people can do at home to demonstrate Newton's laws of motion. This is connected to the statement of inquiry because Sir Isaac Newton was a major mathematician and also the father of calculus, and by using observations, he was able to create the force equals mass times acceleration formula as well as the other laws of motion. There are several possible rubrics that you can use for this. I chose B and C because I would like for the scholars to actually develop the experiments and do the experiments to describe them. Criterion B deals with developing the experiments, and criterion C deals with evaluating their data and their outcomes. If you would rather use criterion D to emphasize a different aspect of the GRASP assignment, I could see using criterion D as a possibility as well. The approaches to learning and the learning experiences that I'm going to focus on during the physics unit have to do with writing. Both in communication skills and critical thinking skills, I would like for scholars to be able to formulate an argument based on evidence and then express their argument in written form. To do that, I will explicitly teach CER paragraphs, how to write them, how to write lab reports, and summary paragraphs and short answers in essay form. Some obvious differentiation you can do in the physics unit has to do with the calculation of the physics problems. You can create problems that are more difficult or less difficult based on the units you select or the use of decimals. Keep in mind that this year scholars should be able to use a calculator on their science STAR test, so you should start practicing using a calculator in class as well. To make some of those problems more difficult for your Q4 and Q5 scholars, you can use non-standard units such as feet, miles, or pounds to give them a conversion problem and have them think about how they need to change centimeters into meters in order to do this, or feet into meters in order to more accurately calculate their answer. Almost all of the formative assessments will have an element of explaining conceptually using a paragraph. Real-world connections that are easily applied with Newton's laws have to do with seat belts and safety equipment. You can make safety equipment into a debatable by bringing up, should we regulate people's behavior based on safety by having click it or ticket campaigns, or should we allow people to make their own choices based on their safety? And can you use Newton's laws of motion to support your opinion in this matter? Lesson 5.1 of the textbook has to do with gravity and friction. I usually take that section out as it doesn't directly relate to some of the TEKS that we need to teach. However, it is a good introduction and also a good reminder of what they should have learned in 6th grade dealing with gravity as a force. For the physics unit, I am personally planning 7 days of new material instruction, 2 days for the GRASP assignment, and then 1 day for the unit exam. This totals up to 10 A and B days for Unit 2, which should put you in the beginning of November or the first week of November to finish up Unit 2. If you are waiting till Thanksgiving to finish Unit 2, you're cutting yourself short for Unit 3, and this year Unit 3 will be on the CA, so make sure you have plans for that. On the unit plan, I start with balanced and unbalanced forces. This year in my own classroom, I'm going to experiment with starting with speed, velocity, and acceleration, then moving into balanced and unbalanced forces, and then lastly covering Newton's laws of motion. So I'll let you know how that turns out. Traditionally, I've started in the order that the TEKS are presented, with 6A being the motion of objects due to unbalanced forces, 6B being speed, velocity, and acceleration, and 6C being Newton's laws of motion. Traditionally, with the STAR test, 8.6a, which is the motion of objects due to unbalanced forces, is usually a calculation TEK. And so a lot of times if you see the force equals mass times acceleration formula, they are applying that with 8.6a. Even though that formula is explicitly stated as Newton's second law of motion. So whenever you're doing exit tickets and planning in class, you'll want to bring up that calculation aspect and more closely associate that with 8.6a and have 8.6c be more of a conceptual understanding of Newton's laws of motion. Next, I have speed, velocity, and acceleration. I will usually do an actual lab with the scholars where they calculate speed. They will measure the time it takes for an object to go a distance, they will graph that, and then they will calculate the speed of the objects. Then usually I will split them into groups and have each group talk about speed, velocity, or acceleration, and then share that out with the class for day 3. I will use this type of gallery walk or puzzling format for speed, velocity, and acceleration because, like I said, it is a supporting standard. If you covered it in depth by yourself, you may spend 2 or 3 days. By having the kids do a jigsaw activity and then bring it all together, you can cover speed, velocity, acceleration, motion, and displacement all in one day. After that, you start Newton's laws of motion, and I will usually plan 1 law of motion per day. These go best in order, so you talk about the law of inertia first, and then notice on the exit ticket it is a conceptual understanding of Newton's laws of motion. We then go to the law of force acceleration, and then lastly, we will move to the law of action and reaction. On the last day, day 7, I will usually put them all together, and then we talk about how no one system is only one law of motion, and that several laws of motion can apply to one situation. Please feel free to email me at atroxel@uplifteducation.org. Thank you.